Okay, let's look at this problem. This problem, there are more algebras inside. Let the identity matrix be I3, means here is 3 by 3. 3 by 3. So here is actually means that. Okay, so if you want more details, here would be I3 means here is a 3 by 3 identity matrix. Okay, again A is 3 by 3 also, in 3 rows, 3 columns. Okay, so we let this I be this one, because we here only talk about 3 by 3. If you write I, sometimes people think this might be 4 by 4 or 2 by 2. But in this example, it's 3 by 3. So let I be the identity matrix. You see the diagonal is 1, 1, 1. So they all are, the rest of them are zeros. This matrix is called identity matrix of order 3. Means it's 3 by 3 dimension. Now, let A be this one. What's the meaning for that? This f of x. Let f of x be this one. I'll figure out. I'll let you. We'll together figure out. What's this? This is a polynomial actually. In study of matrices, f of x is called the characteristic polynomial of A, because A is involved right here. Okay. If it's B, then we call this would be the characteristic polynomial of another matrix B. Okay, here is A, so we call the characteristic polynomial of A. Now, here what we need is that, and zeros right here of f of x are the characteristic values of A. Those two are terminologies. Okay? Yeah. Those two are, one is called characteristic values, another is called characteristic polynomial. Okay. Now, first of all, we need to find out the polynomial f of x. And then we need to find out zeros for that. And again, things is that how is this defined? That's what we need to figure out. We know A is given. A must be given. Otherwise, we cannot find it. And then we know the identity matrix is given in this way. Then what's the meaning for A times x, I? X is a variable. Okay, this is a variable. X is a variable. Now you know, then A times a variable times the matrix, identity matrix. A, you are given right here. That's from here. Minus x. X is a variable, or you may say can be any value of a constant. So x times this matrix, identity matrix. Okay. X times I means x times this identity matrix. Okay. Remember, a variable, a constant, times a matrix means this constant times every element inside. X times 1 is x. X times zeros, so that's still 0. Okay? X times those two zeros are 0, but x times 1 is 1. Okay? X times those two zeros, we got zeros. And x times 1, we got x. Okay? So minus, we still keep it. And here is A. Now, remember again, recall how did we did subtraction for two matrices. We use negative A times x, minus x. Negative 8 minus x. 0 minus 0 is still 0. 0 minus 0 is still 0. Okay, only the first one, negative 8 minus x, negative 8 minus x is like this. Okay, 1 minus 0, 1 minus 0 is 1 right here. 0 minus x, 0 minus x is negative x. Negative 3 minus 0 is negative 3 minus 0. So you got negative 3. Okay, and then negative 2 minus 0. Then we have negative 2. And then 1 minus 0. Right here, 1 minus 0, we have a 1. And then negative 4 minus x. We have a negative 4 minus x here. Okay. Alright. So we figured out a minus xi is actually this one. Is actually only the diagonal minus the variable x. You can see that. The rest of them, because they are zeros, so it does not have an impact on those elements on the diagonals. 0, 0, negative 3, 0, 0, negative 3, 1, negative 2, 1, 1, negative 2, 1. Okay? They are the same. Only negative 8 minus x, 0 minus x, negative 4 minus x. So that's what we get for what? For a minus xi. And then we have here, this means the determinant. We only find out a minus xi is this matrix. Then what's the determinant? Okay, so let's figure out the determinant. Since here again we have two zeros, here this one, the first one is negative 8 minus x. That's on the first row, first column. This 0 is first row, second column, so I wrote 1, 2 here. This 0 is 1, 3. Okay, row 1, column 3. Okay, remember you can find out the determinant of this matrix by expanding the determinant along the first row, because we like zeros. 0 crashes many things. Okay, this number looks like is what? Yeah, the from here. You see negative 8, negative x. This is the element from here times the cofactor. Times the cofactor a11. And then here is 1, 2. That's 0 times the cofactor. And 0, here 1, 3. 0 times the corresponding cofactor 1, 3. Okay? You know, it doesn't matter what those two are, because there are zeros in front of it. So 0 crashes this one, you got 0. 0 times a13, you also get 0. So you don't need that. You only need is negative 8 times minus x, and then a11 cofactor. How is this defined? Again, 1, 1 tells us the negative 1 to the exponent here is 1 plus 1. Okay, and then here you then have a a11, you cross out row 1 and column 1. Okay, a11 is cross out row 1 and column 1. So you get negative x, negative 3, 1, negative 4, negative x. Okay, right here. Alright, now we know negative 1. Yeah, again, this whole thing is a11. That's why I put a remark here. Negative 1 squared is 1. Negative x minus x still are the same. The only thing here is what? Is this one. Negative x times negative 4 minus x minus always minus 1 times negative 3. Okay? Now, we do the distribution thing right here. Negative x times negative 4, positive 4x. Negative x times negative x plus x squared. Negative 1, negative 3 times each other, positive 3. Okay? So here, 1 times anything is anything, so you may forget about this one. And here we want to put the negative sign out, because you know negative x is negative 1 times x. Negative 8 is negative 1 times 8. So we put negative 1 out. Then we have x plus 8 left. And here we still keep this factor down to here. Now this factor times this big factor is x times everything inside, and 8 times everything inside. X times x squared is x cubed. X times 4x is 4x squared. And x times 3 is 3x. So you get the answer for x times everyone here. 8 needs to multiply everything inside. So 8 times x squared plus 8 times 4x. 4 times 8 is 32x. And 8 times 3 is 24. Okay. And then you add 4x squared, 8x squared. 4 plus 8 is 12. And you have a negative from here. Negative again goes to everyone. Okay? So you see negative goes to x cubed. You have that. You add those two together is 12, and negative put in front of it. You add 3 and 32, that's 35. Negative goes there. Negative 35x. 24 positive, negative sign put right here. So we are done with finding the polynomial. Again, this polynomial is called the characteristic polynomial of matrix A. Okay, that's what is written. F of x is the characteristic polynomial of A. Okay, of this A. Okay, again, A must be given for you to do those things. Okay, now we need zeros to find zeros. To find zeros, we don't want to start from here. That's miserable. We want to start from where? From here, the factored one. Okay, so we want to find out f of x is 0. If f of x equals that, it also equals that. Okay, this is your final answer. But when we find zeros, when we are going to find zeros, we use this one, because this is factored one. We don't need to factor it back. We all want to use the already factored one. Now negative 1 right here, x plus 8 right here. We know x squared plus 4x plus 3 right here, and 3 is 3 times 1. 3 plus 1 is 4. So then we know x squared plus 4x plus 3 is x plus 3, x plus 1. Okay. Now x plus 8, you keep it. Negative 1, you keep it. Now 3 factors times each other is 0. At least one of them could be 0, or all of them could be 0. Negative 1 is not 0, so you don't need to consider that. Then you know x could be negative 8, because negative 8 plus positive 8 is 0. Then this factor is 0, it crashes all the whatever here they are. So we have from here, we have x is negative 8. From here, we have x is negative 3. From here, we got x is negative 1. So negative 8, negative 3, negative 1 are the zeros for f of x. And then we call those 3 values are what? Right here. Characteristic values of A, of this matrix. Okay, those two are just terminologies. You will see those two in linear algebra, but no more in this lower level class. Okay, so again, A must be given. Find out A times x, A minus xi first, and then you expand along the convenient row or column. Here we see two zeros. So we do along the first row. Sometimes if you are lucky to have these two are zeros, these are not, you may expand along this one. Here is a little bit nice. So we have a 0, 0 here is convenient. Okay. Please review this lecture. I'll see you next time.